have our final project one presentations. So welcome to the ni, and then you are given 10 minutes to present. 10 minutes. 10, betul kan? 10 minutes.
15 minutes.
15. Sebab dah plus Q&A session lagi kan? 15 tu termasuk dengan Q&A session, betul?
I think 30 minutes.
30! Too much! Let me see, ada timetable. Wait. 30 is too much. Banyak.
Boleh short kan?
Ni, wait, mana dia? Okay, 9:30. Oh, 9:30.
30 minutes.
Setengah jam. Okay. 30 minutes plus Q&A session. Right. Okay, you may start now.
Assalamualaikum warahmatullahi wabarakatuh and very good morning. Alhamdulillahirabbil alamin. Wassalatu ala asyrafil mursalin sayyidina Muhammad wa ala alihi wasallam. Before we start, I would like to thank to my panels, technologists, Dr. Rizol binti Ahmad, for giving me this opportunity to present about my project. Before we start, I would like to apologize for my broken English during my presentation. Let me introduce myself. My name is SYAHRUL Naim RIZOL. My metric number 2013-10892. My project title, before that, I am a year 3 student in machining program. My project title is Experimental Performance of Copper Oxide and Aluminum Oxide Nanolubricant in Refrigeration System for Domestic Use. My supervisor is Dr. Ahmad alias Ahmad Sowi. This is my Gantt chart that I include with my planning and done work during this semester, starting from week 1 until week 13. Let's go through with the introduction. In chapter 1. First, introduction is refrigeration is the process of extracting heat to lower temperature. Refrigeration is used in everyday life, especially at home, which is in our life. The refrigeration is the most important in our daily life, whether in industry or household. The use of refrigeration system is widespread throughout many industries, as well as in household, automobile, and solar application. In simple words, the refrigeration system is the pillar of modernity. Next, in refrigeration system, there are many types of the refrigerant cycle. Many that exist in the world, but I would like to give the example. For example, the refrigerant cycle, such as vapor compression refrigeration, which is called as VCR, absorption cycle, thermoelectric cycle, and gas cycle. But in this study, we use VCR system, vapor compression system, with a vapor compression cycle. VCR circulates liquid refrigerant through a 4 steps of alternately compressing and expanding it and turn it to from liquid to vapor, within liquid to gas. Both of the evaporator and condenser, which consists of coil, to increase surface, which is increase surface, and then it can improve the heat transfer. A little bit of knowledge about nanoparticles. There are several types of nanolubricants that exist, especially for the research to do their research. Researchers to do their research. For example, carbon, silver, and copper. Nanolubricant is the new technology, which is the demonstrate improved thermal tribological properties of lubricants. And in simple words, by using nanolubricant that can decrease refrigerant and compressor power consumption. Nanolubricant enhance or improve refrigeration system effectiveness and reduce component wear, which is you can say it long lasting for especially for the refrigeration system. Next, there are some problem statements that found before we start the experimental. As we can see, in this world, the use of refrigeration system is more widely used in the world. But some researchers investigate an assumption by 2050. It is anticipated that the amount of electricity used by especially in the refrigeration system, will have increased by more than 30% from the current is 70% of usage of refrigeration system. So here there are 4 problem statements. First, when we use the refrigeration system, such as like we have at household, there are conventional refrigeration system. So the power consumption or high electricity consumption contribute to increase the greenhouse gas emission that can cause air pollution. Next, the current problem with the refrigeration system is their environmental impact and contribution to climate change. So when we use the current or electricity, the high consumption of electricity, which can cause the environmental impact. In addition, the contribution to contribute to climate change. Then, several types of refrigeration system use this type of gas, which is R134A, that have a low thermal conductivity. Low thermal conductivity can cause prevent efficient heat transfer. Prevent efficient heat transfer. But some of R134A gas consider thermal conductivity of 0.08 to 0.09 volts per meter Kelvin at 15 degrees Celsius. The last but not least, a low coefficient of performance, as simply words is COP, result in high energy consumption and cooling capacity decrease with a low COP. When the cooling capacity decrease, the energy consumption will increase and lead to higher operating costs and can cause environmental impact. In this study, there are 2 objectives that we refer to run the experimental. First, the objective of this study is to evaluate effect of if nanoparticle volume fraction to the thermal conductivities of copper oxide, aluminum oxide of nanolubricant fluid. Next, to determine the effect mass flow rate of copper oxide, aluminum oxide in nanolubricant to the COP or coefficient of performance of refrigerator system, especially for domestic use. Based on this study, I would like to tell I scope some important elements to do my experimental of this study. First, hybrid nanolubricant is one that combining two or more different kinds of nanoparticle with various characteristics. Utilizing multiple types of nanoparticle can result in better performance. As we can say, utilizing multiple types of nanoparticle can result in better performance than utilizing just one type. The performance of hybrid nanolubricant in refrigeration system has been researched by researchers, and some have shown that they work better than single component of nanolubricant. That's why we have mono nanolubricant or hybrid nanolubricant. So for my study or for my experimental, we use two elements, which is copper oxide and aluminum oxide. So we can call it as the hybrid process or hybrid method. Next, nanoparticle that we use, the size of nanoparticle that we use between in range from 1 to 100 nanometer. When the nanoparticle is small, they can improve lubricant properties by increasing the surface area to volume ratio. Next, volume concentration used in the study range from 0.01%, 0.05% to 0.1%. And this study that I scope this study used two-step method for preparing. Actually, the method have two methods. First method called one method. Second method is two-step method. So that why we use two-step method? Because it's more efficient and effective to do nanoparticle preparation. We continue with the chapter 2, which is literature review. Nanolubricant is a microscopic particles that are dispersed in a liquid or gas. They have a number of properties that make them well suited for use in refrigeration system, including high thermal conductivity, low friction, and wear resistant. The addition of nanolubricants to a refrigeration system can improve the system efficiency without modifying the design. We just modify the nanolubricant, and then the design of this system is maintained not little bit modify the system, which is can modify a small meter of tube, just that. But the overall PCR system will not modify. This is because nanolubricant can fill into the gaps between moving parts, which can help to reduce friction and improve heat transfer. In addition, nanolubricants can help to prevent corrosion and wear, which can further improve the efficiency of the system. There are a lot of studies that have shown that the addition of the nanolubricant can improve the coefficient of performance, which is COP, of a refrigeration system by up to 10%. That means that the system can cool the space or produce ice. Refrigerator, when we say refrigeration, our mindset is to make the ice or to cool the food or something, and produce ice efficiently. At the same time, we can save the energy, we can save the environmental, and we can save the money. And overall, nanolubricant are the promising new technology that has the potential to improve the efficiency of the refrigeration system. They are safe and effective. The two elements is important that we study, that we must to make it safely and more environmental friendly. Here, type of nanoparticle that I found during my review the article. Actually, there are several types of nanoparticle that they use in their research, but now I would like to review some of my type of nanoparticle that I review the article or journal. First, graphene. Graphene nanolubricant also can be used to improve the performance of refrigeration system. In this journal, they use graphene as their nanolubricant, and they can increase the coefficient of performance by up 32.5%. Is more and many, and they can reduce the compressor input by up 30.1%. All the system that include in the VCR have compressor that contribute more energy. So by adding the graphene, it can reduce the compressor input by 13.1%. Okay, next. Carbon nanotube and polyalkyl glycol, CNTPAG. By this journal, they use this type, carbon nanotube and polyalkyl glycol, as the nanolubricant, but this type as a powder, not a fluid. But the concept is same. With this more energy efficient alternative to traditional lubricant for refrigeration system. And this nanolubricant has been shown to have improved thermal rheological properties. This means they can transfer heat when the heat transfer is increased and expected efficiently and reduce friction. The compressor is good. As a result, they can potentially improve the energy efficiency, overall performance of refrigeration system. Yeah. Next, the next journal that I reviewed, they use silica oxide SiO2 as their nanolubricant. The aim of their study is same, because the objective of their study improve thermal conductivity, which is related to COP, and then this improve the thermal conductivity and viscosity of POE oil. They use POE oil as their base fluid. So, while combining the nanoparticle and base fluid, also the result, they can also reduce friction as well and wear and prevent corrosion. They are suitable for users in the high temperature. Next, in this journal, they use diamond as their nanoparticle. diamond also can be used as a nanoparticle. Why? Because nanoparticle can be used as nanolubricant in refrigeration system, which is they can improve the thermal conductivity of the oil. At the same time, it can help to improve the efficiency of the system. They can also reduce friction and wear also in the compressor, which can further improve the efficiency of the system. The usage of the diamond nanoparticle has been shown to increase the COP of the refrigeration system by up to 18%. And it has also shown to reduce the discharge temperature of the compressor by up 4 degrees Celsius. The summary of the review that I have reviewed the journal or article about nanoparticle. Every particle involved has its own good characteristic and has their unique properties and advantages. But overall, the objective and advantage, the objective and of by adding of nanolubricant are similar, which is to reduce gas combustion and decrease rate of global warming. When COP high, it can cause the rate of global warming decrease. It overall same high COP, high thermal conductivity, and some of the journal low viscosity. So similarly same. Okay, now there are some journal that I review and focus on compressor oil. There are many of compressor oil that can use in refrigeration system, but in this literature review, I have reviewed some of type of compressor oil. Firstly, the unique compressor oil. There are for mine, vegetable oil is the unique compressor oil because this journal they use waste vegetable oil that can be used as alternative cooling medium in transformer. Sometimes we use POE, PVE, but this time they use waste vegetable oil. Why? Because they say the higher breakdown voltage and thermal conductivity than mineral oil. And then it can reduce the hot spot temperature of the transformer by 3 degrees Celsius. So, by using waste vegetable oil as a cooling medium can reduce environmental pollution and provide economic and environmental benefit. Because they use a waste vegetable oil as their medium, cooling medium, which is they can save budget and more environmental friendly. The next compressor oil that I reviewed the article. Based on the article is polyol ester, or we sometimes we get POE oil when we bought the refrigerator at the site or behind the refrigerator. They can say the right POE. So the POE is the polyol ester. Based on this journal, POE oil and mineral oil are two types of compressor oil that used in refrigeration system. They use POE, adding and mineral at their research study. They found the density of POE oil is 0.98 gram per milliliter, while mineral oil is 0.9 gram per milliliter. And this characteristic of oil make them suitable for use in refrigeration system. The other compressor oil that I reviewed from based on the article is polyvinyl ester, or we can say PVE oil. So this PVE oil is the synthetic lubricant that used in refrigeration system. But PVE oil does not hydrolyze water, which is important for sometimes hydrolyzed water is important element in refrigeration system. So PVE oil is a polymer based oil, which means that it maintains its property despite variation and viscosity. So the summary of the compressor oil that I reviewed the article or journal. Based on this study, my study, POE oil is chosen for this project because it is good for refrigeration system. Plus, it is compatible with a variety of refrigerants and has good lubricating properties and is stable. It can also absorb moisture and is chemically stable. In other words, POE oil is a good choice for refrigeration system because some research found that it can work well with different refrigerant, keep the compressor running smoothly and prevent the system from corroding. Sometimes the compression doesn't work smoothly by the different refrigerant.
5 minutes more. It's already 9:38.
So now,
Skip the. Can you skip the header? You go straight to methodology, right?
okay, now chapter 3, methodology. The methodology section in this study outline the specific approach and procedures employed to carry out the experiment that evaluate the performance of copper oxide and aluminum oxide. In refrigeration system, it describes the steps taken to set up the experimental apparatus, prepare the copper oxide, aluminum oxide refrigerant, and very relevant variables such as refrigerant, concentration, pressure, and temperature. This section also highlight the measurement and data acquisition method used to collect data on various performance parameters. This is a general flow process method that we conduct. First, development of experimental setup, nanofluid preparation, thermal properties characterization, stability test, and we can obtain the cooling effect or COP analysis. This is schematic diagram. This is compressor, and then condenser, liquid reservoir, filter dryer, capillary tube, and evaporator. This is the most important in the VCR system. The red line is the high pressure. So it starts from compressor and and then at this they are change pressure, which is it turns to low pressure, and then, and then they circulate ada more. Okay. So as I said later, just now, this is the most element of equipment that have in VCR system. So, nanofluid preparation, this is the general process chart. First, we begin the mass of the nanoparticle, mixing the nanoparticle with the base fluid. This process by using Branson sonifier ultrasonic liquid, which is FTKM is 19. So we use Branson sonifier ultrasonic. Hybrid nanofluid is produced. After this is that, and then the nanofluid is produced, and then we put store in the beaker. Here are some theoretical calculation, which is we use 0.05, 0.01, and 0.1. This. And then the POE, the quantity of POE 100. This parameter we use based on this formula that I review from the journal. So this is for copper oxide properties, and this is for aluminum oxide properties. And then this is thermal properties that we found from the journal: the density, the thermal conductivity, and specific heat. This is a general value of copper oxide and aluminum oxide, and this is POE, because for my study we use POE as the base fluid. But later, at the end of the study, to get the density, thermal conductivity, and specific heat and viscosity, we use to this is the decimeter. We use to calculate the density of nanofluid. So nanofluid, and then the thermal conductivity and specific heat we can obtain from by using this equipment. They call KD2 probe, and this is a viscometer to find the viscosity value. At the end of the study, this is a theoretical formula to calculate coefficient of performance, and this formula is the second law of thermodynamic definition, which is called Carnot. So to find the COP, we must know the T low divided by T high minus T low. Okay, that's all from me. This is a reference, but some reference